Alright, so basically this set of videos is not about, making an oscillator. It's about changing your fuse settings. So that's just what I'm just kind of trying to get across. Even though I just had to change some of the settings in my low byte, my low fuse, you may want to do it in your high fuse or your extended fuse bytes. It just depends on what you want to do. And also remember, I'm not an expert. I'm a beginner slogging through this stuff. So proceed with caution, but don't be afraid to make mistakes because I've made plenty of them myself. So basically, we had this nice readout from doing our AVR do command with the verbose -v-v, and so we got our factory settings here. So I wanted to know everything there was, kind of fully understand what was going on before I was going to actually write to my chip. I wasn't just going to, do it half-ass and just say, take a guess at it. So I really wanted to understand what was going on. So basically, I scanned my factory settings here, and then I tried to interpret the numbers it gave me as to what's really set on my chip. So basically, I had to go in and convert the hex number. We'll start with like the low fuse setting here. The hex number is 62. So I just went to a piece of paper and translated the 62 into translate this into a byte and ones and zeros to see what, and then lined up those ones and zeros with the bytes here. In this case, where we're on the low fuse here. So I'd convert the 62 to a byte, and then just line up the ones and zeros along the column here and see what they had set at the factory. And I knew from doing research what the factory settings are, and then if this matched what the factory settings are supposed to be, then I know I'm kind of in the right track, and I'm kind of starting to understand what's going on here. So anyways, excuse my horrible paint program here I'm doing with a mouse, so it's really gonna suck. But basically, we got 62 hex, and so I wanted to convert it into a byte. So you just split the 62 in half. I put a 6 on one side and a 2 on the other, and then to set up your, it's what was hex is like base 16 or whatever. So you just set up 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. And we want to make a 6 out of these. So how do we do that? Well, 2 times 2 is 4, and then 2 to the 1 is 2. So we can make a 6 that way. So we can put a 1 for each one of these, basically enabling those bits, and then 0 for the other ones. Alright, so we have the first half of the byte. And then the next one's the same way. We have a 2, so 2 to the 1 is a 2. So I'll put a 1 here, and the rest of these are going to be 0. Okay, now we have our full byte, our full 62 byte factory setting here. So let's find out what they said at the factory, how it was set up. So basically, let's open up another blank page here. Basically, I just took the byte from highest to lowest and just wrote it out vertically. We're going to 0, 1. That's a 1. It can only be a 1 and a 0. I feel like I'm in kindergarten. Okay, I'm at this 0 now. Next 0, a 1, and a 0. Alright, so go over here, look at our byte settings. Move this around. Alright, so we got a 0 on the first one. So clock, and remember, when a bit is enabled, it's a 0, and when it's not enabled, it's a 1. So in this case, the first bit 7 is enabled. This is our clock divider bit, which makes sense because, you know, from the factory we're using the internal oscillator, and they use that divide by 8 for the internal oscillator, so that's set, so that makes sense. Next one is clock output, and that's a 1, so this clock output bit number 6 is unprogrammed, it's not set, so they're not using the clock output, which kind of makes sense too. You know, from the factory, you're not using a clock signal coming out of it unless you specifically want to set it. And if you want to set a clock output signal, then you would set this bit 6, which would change, you know, the 62 number from the program, you know, that we originally had from the program factory settings, would change this whole bit. And what we got? We've got SUT1. Let's see if I'm out of order. 0, clock division, clock out. Okay, SUT1 is set, and then SUT0 is set, and clock select 3. I'm already screwing up the order, aren't I? Hold on. Alright, sorry about that. I was getting a little mixed up. Best way is I just realigned this box so that the numbers kind of match a little better to the columns. I was confusing myself. So we had the clock division was set, clock out not set, SUT1 was not set, SUT0 was set, and then clock select 3 and clock select 2 were set, and clock select 1 was not set, and then clock select 0 was set. Okay, and then basically I did that for the low bytes, and then I'm going to do the same thing. Okay, so we're going to do the same thing. I just erased the stuff I had on there. Do the same thing for the next bit. This is for the high fuse, and we got a factory setting of 99. So, second we get pencil. So basically, we're going to do the same thing again. We're going to convert 99 into a byte, and then see what the settings are. So once again, we have 9. So we have 2 to 3, 2 times 2 is 4, times 2 is 8, and then 2 to the 0 is 1, so we can make those both 1s. Then I'll leave the rest with 0s, and of course it'll be the same thing here. Alright, so once again here we have our, this is going to be our high byte, and go over here, and alright, so I erased the stuff here. Okay, so we're going to write down our byte, remember, from our highest bit down to our lowest. So we had a 1, and we had a 0, a 0, a 1, another 1, a 0, a 0. Alright, I'm done butchering the English numerical system. Okay, so let's see what we have set here. This is our high byte from our data sheet. And okay, so it looks like the on-chip debug enabled is not set because it's a 1. That makes sense because I'm coming from the factory. And the JTAG enabled is enabled. It's set to 0. And then we have our serial peripheral interface enabled. which is set. That makes sense. Otherwise, you wouldn't be able to program your chip. So you can tell if you're translating this stuff right, and the things seem to match. You kind of get an idea you're on the right track, and you're starting to understand. You're translating converting the hexadecimal to bytes, and then reading the bytes right off the charts. And so, if you understand that, if you can scan your chip and then convert, the settings and then look in your data sheet and everything seems to match, then it's going to help you when you have to set and create those 3 or maybe just 1 byte you want to change, maybe just the lower fuse byte you want to change. When you want to create that byte, then you'll have a better understanding of what you're doing, which one you're changing, and if everything matches, because you want everything to match and everything feel comfortable with before you zap your chip. That's the way I felt. And when everything seemed to kind of match up, I felt comfortable. Okay, I don't mind. I don't mind zapping my chip if I screwed something up. At least I understand, what's going on. Okay, so basically, I'll pick up in the next part, the next video, actually creating the bytes that we're going to write to the chip. See ya.